Quick headlines before the intro. This is the UGTP Weekly AI Mega for the week ending June 6th, and the theme is not one model winning one benchmark. The theme is AI becoming an operating layer. OpenAI started rolling out a more scalable ChatGPT memory system called Dreaming and added lockdown mode across logged-in users. GitHub turned Copilot Cloud Agent tasks into an API, added 1 million token context windows, expanded billing and budget APIs, gave users one-click Copilot fixes for failing actions, and deprecated GPT 5.2 and GPT 5.2 codecs across most Copilot experiences. Anthropic mapped 832 banned cyber abuse accounts against MITRE ATT and CK and argued that AI-enabled attacks are becoming more autonomous. NVIDIA released Cosmos 3 on Hugging Face as an open omni-model family for physical AI. Mistral pushed Search Toolkit for production retrieval. Microsoft Build gave us agent sandboxes, WorkIQ, model choice, and low-token cost agent infrastructure. The short version: the industry is moving from chat features to memory, context, tools, security, budgets, sandboxes, and automation. Receipts up, hype down. Let's lock in.
Powered by artificial intelligence.
The newest OpenAI story this week is not just memory. It is memory plus security. OpenAI says Dreaming is a more capable and scalable system for synthesizing memory in ChatGPT, built to handle staleness, correctness, and scale across hundreds of millions of users in multi-year time horizons. In practical terms, the assistant is supposed to remember useful context without clinging to old or contradictory details. That matters because memory is not a cute personalization trick anymore. If ChatGPT helps with long-running projects, career work, family planning, codebases, and research, the quality of memory decides whether it feels like a collaborator or a stranger with notes. The rollout details are also important. OpenAI says the update is available to Plus and Pro users in the United States first, with expansion to additional countries and free and Go users over the coming weeks. The Help Center notes that Plus and Pro users can also get twice as much memory capacity. Users can review memories through sources or the memory summary, and those who prefer the legacy save memories model can switch back in settings. That is the right product tension. Automatic memory can be powerful, but it needs visibility and control. Then comes lockdown mode. OpenAI says it is now available to all logged-in users across account types and workspaces. It is an opt-in advanced security setting that restricts network-enabled capabilities like live browsing, deep research, agent mode, file downloads, and some web-derived image support. The reason is prompt injection and data exfiltration. If an AI system can browse, download, call tools, and read sensitive context, a malicious page or instruction can try to trick it. Lockdown mode is not glamorous, but it is one of the clearest signs that AI products are entering the security maturity phase. More memory and more tool access are useful only if users can decide when the system should be sealed off. The newest GitHub story is model churn. On June 5, GitHub said GPT 5.2 and GPT 5.2 codecs are deprecated across most GitHub Copilot experiences, including Copilot Chat, inline edits, Ask Mode, Agent Mode, and code completions. GitHub lists GPT 5.5 as the suggested alternative for GPT 5.2, and GPT 5.3 codecs as the suggested alternative for GPT 5.2 codecs. There is one notable exception. GPT 5.2 is still available as part of Copilot Code Review. This sounds like a small changelog entry, but it is a big enterprise reality check. Coding assistants are no longer stable wrappers around one model. They are model fleets. One model becomes the default, another becomes deprecated, another is allowed only for code review, another needs an admin policy toggle, and another may cost a different number of credits. Developers may experience that as a drop-down. Enterprises experience it as governance work, approval, security review, legal review, performance testing, cost forecasting, and internal guidance. The lesson is not that model churn is bad. It is that model lifecycle management is now part of software development. If your workflow depends on an agent model, you need to know what happens when the model changes. Does it write different tests? Does it produce larger patches? Does it use more context? Does it need fewer retries? Does it behave differently on security-sensitive code? GitHub tells enterprise admins they may need to enable access to alternative models through model policies in Copilot settings. That sentence is the whole week in miniature. AI is not just a feature you turn on. It is a managed platform with versions, policies, costs, and blast radius. The next new GitHub story is not flashy, and that is exactly why it matters. GitHub says budget and usage management APIs are now generally available. That means teams can programmatically create, update, delete, and adjust budgets, along with alert notifications. The new Usage Summary API can retrieve usage for an entire account or filter by organizations, repositories, cost centers, products, or SKUs. A separate changelog says enterprise administrators can now request and download billing usage reports in CSV format through the REST API. This is the financial control layer for agentic AI. Last week, people could talk about agents as productivity. This week, the platform is saying, show me usage by repository, by organization, by product, by SKU, by day, by month. That is what happens when AI coding stops being a novelty and becomes infrastructure spend. If Copilot code review, cloud agents, long context chats, and model choices all consume credits or compute, then finance and engineering need the same kind of observability they expect from cloud services. For developers, this may feel distant. For engineering leaders, it is central. You cannot scale autonomous work if you cannot cap it, measure it, and explain it. A runaway agent that opens repeated sessions, reads a million tokens unnecessarily, or retries a failing workflow for hours is not just annoying. It is a cost event. The budget APIs also hint at a future where internal developer platforms can enforce AI usage policies automatically. Maybe high-cost models are allowed only on certain repositories. Maybe code review budgets differ by team. Maybe experimental agents run in a capped cost center. This is not hype. This is the boring machinery that lets AI survive procurement, finance, and production operations. Now to the kind of feature users will actually feel. GitHub says Copilot Pro, Pro Plus, and Max subscribers can now ask Copilot Cloud Agent to fix a failing GitHub Actions job in one click. The workflow is simple. When an Actions job fails, the user clicks Fix with Copilot on the Workflow Run Logs page. Copilot investigates the failure, pushes a fix to the branch, and tags the user for review when it is done. GitHub says the work runs from Copilot's own cloud-based development environment. This is small, direct, and probably sticky. Failing CI is one of the most common friction points in software work. Maybe a test snapshot changed. Maybe a linter rule broke. Maybe a dependency version shifted. Maybe a workflow path is wrong. A senior engineer can often fix it quickly, but the interruption costs focus. The promise here is delegation, hand off simple but time-consuming failures and stay in the work you wanted to do. The risk is also clear. A CI fix is still a code change. If an agent patches a test by weakening the assertion, hides a real failure, or changes a workflow in a way that makes later deployments less safe, the team loses more than it gains. That is why the review step matters. The best version of this feature is not Copilot fixed it, ship it. The best version is Copilot investigated, produced a patch, and gave the human a reviewable diff. This is the pattern we should expect everywhere. Agents will take the first pass at repetitive operational tasks, but strong teams will keep evidence, diffs, checks, and accountability in the loop. The most serious security story of the week comes from Anthropic. The company analyzed 832 accounts banned for malicious cyber activity between March 2025 and March 2026, then mapped activity against MITRE ATT and CK. Anthropic says these accounts are only a subset of total banned accounts, but they had enough detail for a deeper assessment. The findings are uncomfortable. Attackers are using AI in ways that make them more dangerous. AI can chain together parts of the attack lifecycle, and existing security frameworks do not fully capture what AI-enabled attackers can do. The numbers matter. Anthropic says 560 of the 832 studied accounts, or 67.3%, used AI for malware-related preparation. 54 accounts, or 6.5%, used AI to assist with lateral movement, which means navigating deeper inside a compromised network. Anthropic also says the share of actors classified as medium risk or higher rose from 33% in the first 6-month period to 56% in the second, roughly a 1.7-fold increase. The real warning is not that every attacker is suddenly elite. It is that AI changes the relationship between skill and capability. Anthropic says the number of techniques used or the interface selected did not correlate strongly with risk level. What mattered more was where in the attack lifecycle AI was applied and whether attackers built scaffolding around the model to chain stages together with little human input. That is the agentic security concern. A chatbot that drafts phishing copy is one problem. A tool-using agent that discovers accounts, escalates privileges, runs commands, and adapts in real time is a different category. Defenders need frameworks that recognize orchestration, autonomy, and model-assisted decision-making as threat behaviors in their own right. The other Anthropic story this week is business infrastructure. Anthropic announced the services track and partner hub for the Claude Partner Network. The company says more than 40,000 firms have applied to join the network and more than 10,000 consultants have earned a Claude certification. It also lists major services firms building Claude practices, including Accenture training 30,000 professionals, Cognizant rolling Claude out to roughly 350,000 associates, Deloitte making it available to 470,000 people, and KPMG integrating Claude across more than 276,000 workers. The new services track has 3 tiers: Select, Preferred, and Global Premier. The requirements are not just "we like Claude." They are operational, active certified individuals, joint customers deployed in production, public customer stories, and in the top tier, deployments across 3 or more regions plus a joint business plan. The Claude Partner Hub lets partners see standing against requirements, refresh daily, and gives customers a directory of qualified firms. Why put this in an AI news mega? Because it shows how enterprise AI adoption actually happens. Models do not magically deploy themselves into banks, manufacturers, hospitals, public sector agencies, and law firms. There is integration, evaluation, change management, training, data access, security, procurement, and workflow redesign. Anthropic is building the channel layer around Claude, and the numbers suggest consulting firms see AI implementation as a major business line. The risk is that partner ecosystems can become marketing fog. The useful part is visible requirements, certifications, production deployments, public customer references, and quarterly verification. In the enterprise, AI competition is not only model versus model. It is ecosystem versus ecosystem. Google did not just publish one new product note this week. It published a June 5 recap of its biggest AI updates from May 2026, and the framing is useful because it tells us how Google wants the market to understand the current cycle. Google says its May update centered on the agentic Gemini era, including Gemini 3.5 for agents and coding, Gemini Omni for reasoning plus creation, proactive tools in the Gemini app, Universal Cart, the Google Health app, and new hardware experiences. This is not the same kind of breaking item as GitHub deprecating a model or OpenAI rolling out memory. But it belongs in the weekly because it gives context. Google is positioning AI not as one assistant, but as a layer across search, creation, shopping, health, devices, developer tools, and agents. That matches the broader story from OpenAI, Microsoft, GitHub, Anthropic, NVIDIA, and Mistral. The companies are not simply trying to answer questions better. They are trying to own the context layer where tasks begin, continue, and complete. The important thing for viewers is to separate product language from platform direction. A recap can sound broad and shiny. The real direction is concrete: more capable model families, agent-focused developer surfaces, consumer apps that act proactively, and hardware that turns AI from a website into an ambient system. The competitive question is not whether Gemini, ChatGPT, Claude, Copilot, or a physical AI model has the best demo this week. The question is which stack gives users the best combination of memory, tool use, search, device access, privacy controls, cost control, and trust. Before we move into the rest of the weekly context, here are the stories to watch next. First, Google and Kaggle's June 15th through 19th AI Agents course is worth tracking because it turns agent building into mainstream education, not just a developer conference demo. When big platforms teach millions of people how to build agents, the next wave of tools, templates, and startup experiments usually follows. Second, watch GitHub Copilot policy changes day by day. This week alone gave us model deprecations, 1 million token context, budget APIs, usage reports, and cloud agent automation. That means Copilot is moving fast enough that teams need a weekly policy check: which models are enabled, which tasks are allowed, which budgets are capped, and which agent features touch production repositories. Third, watch OpenAI's memory and lockdown mode rollout. The tension is obvious: users want assistants that remember ongoing work, but security teams want fewer routes for prompt injection and data exfiltration. The products that win will not simply remember more. They will make memory explainable, editable, fresh, and easy to restrict when sensitive work begins. Story 3 is the feature everyone will notice. GitHub Copilot now supports larger context windows and configurable reasoning levels. GitHub says a 1 million token context window lets users work across larger code bases, longer documents, and complex multi-file projects without losing context. The capability is available now in VS Code, Copilot CLI, and the GitHub Copilot app, with more surfaces coming. Configurable reasoning levels let users dial in the balance of speed and depth, including extended thinking for harder architecture and debugging problems. But the most important line is the cost warning. GitHub says choosing a larger context window or higher reasoning level will consume more AI credits per interaction. This is the new normal. Context is power, but context is not free. If you hand a model 1 million tokens when the task only needs 5 files, you are buying latency, cost, and noise. The smarter workflow is to use default context for everyday tasks and reach for extended context when the task really is complex and multi-file. This is why yesterday's token cost story matters today. The best agent platforms are not just adding bigger windows. They are teaching users when bigger is worth it. Story 6 is NVIDIA Cosmos 3 on Hugging Face. NVIDIA describes Cosmos 3 as an open omni-model for physical AI, combining world generation, physical reasoning, and action generation in one model. The practical point is that developers previously had to juggle separate models for world generation, controlled generation, scene understanding, and policy generation. Cosmos 3 is designed to reason and generate different modalities in one unified forward pass. The release includes Cosmos 3 Nano and Cosmos 3 Super. Nano is described as a 16 billion parameter setup, with an 8 billion reasoner and 8 billion generator, optimized for efficient inference on workstation-grade hardware like RTX Pro 6000. Super is described as a 64 billion parameter setup for large-scale synthetic data generation and research on Hopper and Blackwell GPUs. NVIDIA says the model can generate realistic video worlds, reason about motion and spatial relationships, and predict future video and action sequences. The real significance is physical AI. Agents that live in software need memory and tools. Agents that act in the physical world need simulation, causality, and action policies. Cosmos 3 is one of the clearest signs that world models are becoming the foundation layer for robotics and autonomous systems. Story 7 is Mistral's Search Toolkit. It is not brand new today, but it is directly relevant to today's theme because memory and context only work if retrieval is reliable. Mistral describes Search Toolkit as a composable framework for building production search pipelines for AI applications. It combines ingestion, retrieval, and evaluation under a shared interface. Ingestion handles document parsing, chunking, embedding generation, and custom adapters. Retrieval includes BM25 sparse retrieval, dense embedding retrieval, and hybrid configurations. Evaluation includes recall, precision, MRR, and NDCG. This is where a lot of real-world AI projects succeed or fail. The model is impressive, but the agent cannot answer from your company knowledge if search is brittle. It cannot stay current if live systems and indexed corpora are disconnected. It cannot improve if you are not measuring retrieval quality over time. Mistral also points to agents pulling live data through connectors and MCP integrations while using Search Toolkit as the indexed search path. That combination is important: static knowledge, live state, and evaluation. In other words, RAG is not a prompt trick. It is infrastructure. The lead story is GitHub Copilot in Visual Studio Code, because this is where the token cost issue becomes practical. GitHub says the June 3 changelog covers VS Code releases v1.120 through v1.123, shipped throughout May and early June. The headline product direction is agent-first development, an agent's window and stable preview, remote agents over SSH or dev tunnels, multiple sessions side-by-side, session sync, chronicle commands, and continuing work on the agent host protocol. But the detail that matters for today's video is buried in the terminal safety and efficiency section. GitHub says expanded terminal output compression now covers more verbose output patterns from tests, builds, linters, Docker, and package managers before that output reaches the model. That is the Microsoft token reduction decision we need to pay attention to. Not a vague promise. Not a rumor. A product-level change that reduces unnecessary context before the language model sees it. Anyone who has used a coding agent knows the problem. One failed test command can dump thousands of lines into context. Docker can flood logs. Package managers can print pages of dependency noise. Linters can repeat the same warning in 50 files. If the agent sends all of that back into the model burns tokens reading junk. Compression is not glamorous, but it is exactly the kind of engineering that separates an agent toy from an agent tool. The more agents run commands, the more the platform has to decide what information is signal, what is noise, and what should never be sent to the model at all. Story 2 is the billing shift, because this is the business reason token reduction matters. GitHub says usage-based billing for Copilot is now live for all users. As of June 1, all Copilot plans bill based on GitHub AI credits consumed, and each plan includes monthly usage. GitHub's earlier company blog explained the change directly. Premium request units are being replaced by AI credits, and credits are consumed based on token usage, including input tokens, output tokens, and cache tokens, according to the published model rates. GitHub Docs also says 1 AI credit equals 1 cent in United States dollars. The important part is the logic behind the change. GitHub says Copilot has evolved from an in-editor assistant into an agentic platform capable of long, multi-step coding sessions, latest model use, and repository-wide iteration. A tiny chat question and a multi-hour autonomous coding session cannot rationally cost the same. That is why Copilot now needs budgets, usage reports, pooled included usage for organizations, and model pricing visibility. For viewers, the takeaway is blunt: the agent era is also the metering era. The old mental model was, I paid for my subscription, now I can ask. The new model is, what did this task cost, which model did it use, How much context did it read, and was that context actually necessary? That is why VS Code compressing terminal output is not a footnote. It is part of a broader move to make agentic coding economically survivable. Story 3 is control. The same VS Code release expands bring your own key support, including air-gapped BYOK environments, a custom endpoint provider, a model picker organized by provider, and real token visibility for BYOK models. It also adds reasoning effort controls in the model picker, so users can balance quality, latency, and cost. And it lets teams configure utility models for smaller background jobs like titles, summaries, rename suggestions, commit messages, and intent detection. This is the part many people will miss. Model choice is not just a power user toy anymore. It is becoming a budget and governance surface. If a frontier model handles every tiny utility task, costs climb. If a cheap model handles a complex refactor, quality drops and the agent may retry until the savings disappear. Good agent platforms will route work intelligently, strong models for high-stakes reasoning, cheaper models for repetitive support tasks, compressed logs for noisy command output, and strict controls for sensitive terminal prompts. GitHub even says passwords, passphrase, pins, and verification codes stay in the terminal and are not shared with the LLM. That is the right pattern. The future is not one model doing everything. The future is a stack where context, model, permission, and budget are chosen deliberately. Developers get more power, but they also inherit more operational responsibility. Story 6 is OpenAI's security update. OpenAI's June 2 ChatGPT release notes say active sessions are rolling out as a security feature. Users can review first-party OpenAI sessions from Settings, Security, Active Sessions, with details like device, app, approximate location, sign-in time, trusted device status, and whether the session is the current session. Users can also log out of individual sessions or all sessions. OpenAI says active sessions covers sessions known through session management, including ChatGPT, Codex, and API platform sessions where available, while excluding third-party app sessions and some connected app flows. This sounds ordinary, but in the context of Codex and computer use, it matters. AI tools are moving closer to your machine, your code, your files, and your workflows. When a coding agent can run locally, be steered remotely, and remain connected across devices, account security becomes part of the developer toolchain. A stale session on an old laptop is not just a chat history risk. It can become a project access risk. The same release window also includes OpenAI's Codex Remote Control update for Windows, where users can start work on a Windows machine and steer it from ChatGPT Mobile or Codex on another machine while the Windows host keeps the files, shell, app server, and local context. That is powerful. It also makes session visibility and logout controls less optional. Story 7 is Anthropic's Project Glasswing expansion. Anthropic says the program is moving beyond its initial group and extending to approximately 150 new organizations, each needing to meet security requirements before gaining access. The new group spans more than 15 countries and includes sectors that Anthropic says were not well represented in the initial cohort: power, water, healthcare, communications, and hardware. Anthropic also says many partners are vendors and nonprofits that maintain codebases relied on by governments and other organizations. The most important line is not just the expansion number. It is the bottleneck. Anthropic says the bottleneck in cybersecurity is now verifying, disclosing, and patching the large number of vulnerabilities that Mythos-class models can surface. That is the same pattern we saw in coding agents today. AI can generate more work than humans can review. It can find more logs than context can afford. It can surface more vulnerabilities than maintainers can patch. So the next step is not only stronger models. It is workflow infrastructure, triage verification, safe disclosure, patch generation, rollout, and safeguards against misuse. This story pairs directly with Microsoft's token compression and GitHub's budget controls. Agentic AI is scaling the amount of work generated. Now the industry has to scale the systems that decide what work is real, safe, affordable, and worth acting on. The lead story is Microsoft Build. Microsoft's official build post is not subtle. The company is trying to make agents a first-class platform layer. One of the clearest examples is WorkIQ. Microsoft says WorkIQ APIs will become generally available on June 16, giving agents programmatic access to the context layer that helps them work inside an organization. That is important because enterprise agents need more than a chat box. They need to know which files, meetings, people, permissions, and business context matter without breaking governance. Microsoft also points to hosted agents in Foundry Agent Service, now in preview, with instant-on sandboxes per session, isolated execution, persistent memory, and elastic scale. The analogy Microsoft uses is strong. Hosted agent sandboxes are being positioned like containers were for cloud-native apps. That comparison is useful. Containers gave developers a repeatable unit for deploying services. Agent sandboxes could become the repeatable unit for deploying digital workers. Each session needs a boundary. It needs tools. It needs memory. It needs access controls. It needs a place to execute code, browse, read files, and complete tasks without becoming a security nightmare. That is why Build matters today. Microsoft is not only showing new AI features. It is building the infrastructure shape around agents, context, identity, sandboxing, governance, developer tools, and cloud scale. If this works, the question moves from "can an AI answer this?" to "can an AI safely operate inside the workflow where the answer becomes action?" That is the platform shift. Story 2 is the GitHub Copilot app. GitHub says the technical preview is now available to all existing Copilot Pro, Pro Plus, Business, and Enterprise customers, with free users and non-Copilot users able to join a waitlist. The big product idea is that Copilot is becoming a desktop home for agent-native software development. You can start from an issue, pull request, prompt, previous session, or local folder. You can run parallel agent sessions, each separated by its own worktree and branch. You can review the plan in diff, validate behavior in an integrated terminal and browser, open a pull request, and let agent merge address review comments or failing checks under your conditions. The new feature GitHub is emphasizing is canvases. A canvas is a structured interactive surface where the agent's work becomes visible: a plan, pull request, terminal, browser session, release checklist, migration board, or workflow state. The point is that agent progress should not be buried in a transcript. Users need to inspect state, steer direction, edit the surface, approve steps, and verify progress. The agent reads that same canvas and updates it as it works. That is a big interface clue. We are moving from chat UX to agent experience. Chat remains the place for instruction and ambiguity. Canvases become the place where work lands. For developers, that means the next competition is not only which model writes better code. It is which environment lets humans supervise agent work without drowning in logs, diffs, and repeated course correction. Story 3 is more developer-facing but maybe even more important. GitHub says the Copilot SDK is now generally available. That means developers can embed GitHub Copilot's agentic engine into applications, services, and developer tools with a stable API and production-ready support. The SDK gives programmatic access to the same agent runtime behind Copilot: planning, tool invocation, file edits, streaming, and multi-turn sessions. It is available in Node and TypeScript, Python, Go, .NET, Rust, and Java, with Rust and Java called out as new at general availability. The capabilities list tells you exactly where GitHub thinks agent platforms are going. Custom tools and MCP support let developers register tools that the agent can invoke autonomously. Fine-grained system prompt customization lets teams shape identity, tone, tool instructions, and safety rules without rewriting the whole prompt from scratch. OpenTelemetry tracing gives production teams a way to understand what happened across JSON RPC calls, session operations, and tool execution. Authentication supports GitHub OAuth, GitHub Apps, environment tokens, and bring your own key providers including OpenAI, Microsoft Foundry, Anthropic, and others. That is the real enterprise story. A model is only one part. The SDK gives teams a way to make agent behavior observable, tool-aware, authenticated, and embedded into their own products. This is how Copilot moves from a product into a platform. Story 4 is the runtime layer. GitHub's June 2 changelog includes cloud and local sandboxes for Copilot in public preview, plus Gemini models in Copilot CLI, Cloud Agent, and the Copilot app. Those two updates belong together. Sandboxes answer the question, where does the agent safely run? Model choice answers the question, what brain should the agent use for this particular job? Once agents start editing files, running commands, opening browsers, and touching infrastructure, the runtime cannot be an afterthought. You need isolated environments, permission boundaries, predictable tools, and a way to decide whether work runs locally, in the cloud, or against a repo-backed session. The Gemini update points to another important shift: agent platforms are becoming multi-model. GitHub is not only saying use R1 Assistant. It is making Copilot surfaces support additional models depending on the context and plan. That matters because coding agents are not a single workload. Some tasks need cheap speed. Some need deep reasoning. Some need long context. Some need a model that is stronger at UI code, tests, security review, or repository scale refactors. The future agent stack will likely route across models, tools, and sandboxes based on task shape. For developers, this is both exciting and messy. More choice means more power, but also more cost management, more policy work, and more evaluation. The teams that win will not simply turn every model on. They will decide which model gets which job, in which sandbox, under which budget. Story 5 is the part users will actually feel: billing. GitHub says usage-based billing for Copilot is now live for all users, and that Copilot code review consumes GitHub Actions minutes in addition to GitHub AI credits. It also launched user-level budget controls for organizations and enterprises, so admins can set universal budgets or override budgets for specific users. Copilot Max is available as an upgrade for existing Student, Pro, and Pro Plus subscribers, and new signups remain paused for several individual plans while GitHub reopens access later. This is not just a pricing footnote. It is part of the agent story. Agents do more work per request than classic autocomplete. They plan, call tools, edit files, run checks, retry, and sometimes keep working across sessions. That means the cost model has to follow usage more closely. But it also means developers need better visibility. If one agent session can burn through credits because it explores a big repo, runs repeated reviews, or uses expensive models, users need budgets, caps, and clear receipts. The bigger lesson is that AI coding tools are moving from flat-fee helpers toward metered development infrastructure. For teams, that changes behavior. You start asking whether an agent task is worth the credits, whether code review should run on every pull request, and whether a cheaper model is good enough. Agent productivity and agent cost are now tied together. Story 7 is policy. The White House published a June 2 executive order titled Promoting Advanced Artificial Intelligence Innovation and Security, plus a fact sheet framing the order around cybersecurity, critical infrastructure, and AI leadership. The order directs relevant parts of government to prioritize cyber defense of national security systems, Department of War information systems, and civilian federal information systems. The fact sheet says the Secretary of Homeland Security, working with other officials, should issue guidance to facilitate access to AI-enabled cybersecurity tools and services for federal agencies, state and local authorities, and operators of critical infrastructure, including rural hospitals, community banks, and local utilities. The part that intersects with today's agent story is enforcement and model access. The order tells the Attorney General to prioritize enforcement of federal criminal laws against people who use AI to illegally access or damage computers, including employing AI agents to unlawfully access data. The broader policy signal is clear: governments are treating advanced AI as both a defensive tool and a security risk. This is the same pattern we see in developer tools. The more capable agents become, the more important governance becomes. In companies, that means sandboxes, budgets, identity, tool permissions, and audit logs. In government, it means national security systems, critical infrastructure, model evaluation, and cyber enforcement. The technology is moving fast enough that policy is being forced to respond in real time. The lead story is Vera Rubin. NVIDIA's announcement says the Vera Rubin platform is ramping into full production to power agentic AI factories worldwide, with production shipments set to begin starting this fall. That wording matters. This is not just another slide in a future roadmap. It is NVIDIA telling cloud providers, AI labs, server makers, and enterprise infrastructure teams that the next generation of AI factory hardware is moving into manufacturing scale. The release frames agentic AI as a new kind of workload. One prompt can turn into a long chain of reasoning, retrieval, tool use, context memory, and response generation. That means the system is not only serving a single answer. It may be coordinating multiple model calls, search passes, tool executions, database reads, code runs, and policy checks. The hardware implication is brutal. If agents become the default interface, token demand grows, memory demand grows, networking demand grows, and security demand grows. Vera Rubin is NVIDIA's answer to that pressure. The story is not just faster chips. The story is an entire production stack built around agents that run longer, touch more systems, and need lower cost per useful result. The other important piece is the partner list. NVIDIA names major system builders and infrastructure partners across servers, storage, networking, and software. That tells us the AI factory market is becoming more industrialized. The industry is trying to move from custom cluster projects into repeatable systems that can be manufactured, validated, deployed, and operated like a product. If this works, the bottleneck shifts. It becomes less about whether one lab can build one monster cluster, and more about how quickly whole supply chains can repeat that build across regions, clouds, and sovereign deployments. For viewers, the takeaway is this: agentic AI is pushing infrastructure into a new phase. The models are only one layer. The real battle is the factory that runs them all day without falling over. The second story is DSX, and it is the one that makes the infrastructure theme clearer. NVIDIA describes DSX as a platform for designing, simulating, and operating AI factories. In plain English, building a data center for modern AI is getting so complicated that the data center itself needs a software stack, a simulation layer, and a reference design. NVIDIA's DSX page talks about reference designs: DSX Sim, DSX OS, Max LPS for power efficiency, DSX Flex for grid-responsive power orchestration, and DSX Exchange for connecting compute, energy, power, cooling, digital twins, and operation systems. That sounds like a lot because it is a lot. AI factories are no longer just rows of servers and a cooling bill. They are physical plants that need to optimize tokens per watt, manage heat, handle faults, coordinate power budgets, enforce security, and keep multi-tenant workloads running. The reason this matters is that AI cost is moving from model price into operational architecture. If two companies use similar GPUs but one runs them with better power management, better scheduling, better cooling, and fewer failures, the second company can deliver cheaper inference or more reliable agents. That is why NVIDIA is pushing the language of lowest token cost. It wants buyers to think about the entire factory as the product. This also connects to the energy conversation. If AI factories are pulling huge electrical loads, they cannot behave like ordinary web servers. They need to respond to grid signals, power events, pricing changes, and facility constraints. DSX is NVIDIA's attempt to make the AI factory less artisanal and more repeatable. It is not glamorous like a new chatbot, but it may decide who can actually serve those chatbots profitably. Story 4 brings the factory theme down to the desk. NVIDIA announced DGX Station for Windows, built with Microsoft and powered by the GB300 Grace Blackwell Ultra Desktop Superchip. NVIDIA says the system is designed to build, run, and connect always-on AI agents to Windows applications and workflows, and that it can run frontier AI models of up to 1 trillion parameters locally. The release says it is coming in Q4 from vendors including Asus, Dell Technologies, Gigabyte, HP, MSI, and Supermicro. The headline is flashy, but the real story is enterprise workflow. Most heavy AI development has lived in Linux data centers, while most business users live in Windows, design tools, engineering software, office workflows, file systems, identity, security, device management, and corporate policy. DGX Station for Windows tries to bridge that gap. The specs are also meant to signal that local AI is no longer just tiny models on laptops. NVIDIA lists up to 748 GB of coherent memory, up to 20 petaflops of FP4 performance, a 72-core Grace CPU, Blackwell Ultra GPU, NVLink C2C, and high-speed networking. More important, the release connects the workstation to a security story. NVIDIA OpenShell is described as a secure-by-design runtime for autonomous agents, using Windows security and containment primitives so policies are enforced at the system level rather than depending only on prompts. That distinction matters. If agents can use tools, open files, call applications, and run tasks continuously, please behave is not enough. Enterprises need containment, auditability, identity, and management. This is a big signal. The next wave of enterprise AI is not only about smarter models. It is about giving agents a governed place to live inside the operating system. Story 5 is the most industrial story of the day, NVIDIA and TSMC bringing AI into fabs. NVIDIA says TSMC is using accelerated computing and AI across lithography, transistor and process simulation, advanced process control, fab operations optimization, and defect inspection. The specific claims are worth slowing down for. NVIDIA says CuLitho, its GPU-accelerated computational lithography library, delivers a 20 to 50% improvement in cost-effectiveness or cycle time compared with CPU-based computational lithography while maintaining the same cost of ownership. It also says CuEST, a GPU-accelerated electronic structure simulation library, gives 50 times faster chemistry simulations on average for semiconductor material design. On inspection, TSMC is using NVIDIA Metropolis and TAO Toolkit for automated defect inspection, including nanometer-scale defects. Why does this matter beyond chip nerds? Because the AI boom is constrained by chips, and chips are constrained by manufacturing complexity. Advanced nodes require intense simulation, mask design, process control, equipment coordination, and inspection. Every improvement in cycle time, yield, and defect detection can ripple through the entire AI supply chain. If fabs get better at using AI to make chips, then AI becomes part of its own manufacturing loop. That is powerful and also slightly circular. We build better AI chips with AI, then use those chips to build bigger AI systems, then use those systems to optimize more manufacturing. The sober version is this: none of this magically eliminates fabrication bottlenecks, packaging constraints, energy limits, or supply chain risk. But it does show that the AI story is now embedded deep inside the physical process of making silicon. The cloud begins in the fab. Story 6 moves from data centers to the road. NVIDIA introduced Alpamayo 2 Super, described as an open 32 billion parameter reasoning-based vision-language action model for safe Level 4 robotaxi development. The release says the model reasons, plans, and acts across the driving stack. It also introduces AlpaGym, a high-throughput closed-loop reinforcement learning framework that trains autonomous vehicle models on the consequences of driving decisions in simulation, and OmniDreams, a generative world model for photorealistic closed-loop autonomous vehicle scenario generation. This is an important shift because autonomous driving is not just perception. Seeing the lane, detecting a pedestrian, or recognizing a traffic light is not enough. The hard problem is deciding what to do when the scene is weird, rare, ambiguous, or socially complicated. The phrase vision-language action matters because it connects perception, reasoning, and control. A VLA model can, in principle, reason over what it sees, interpret instructions or scene context, and map that understanding toward actions. But this is also where caution belongs. A model announcement does not mean robot access are solved tomorrow. NVIDIA is pitching an open development stack for safer, scalable Level 4 development, not declaring that every city is ready for driverless deployment. The key contribution is the pipeline: real-world data capture, neural reconstruction, simulation, closed-loop training, generated rare scenarios, and in-vehicle deployment. Autonomous driving needs exactly that kind of pipeline because the road contains long-tail situations that are too dangerous or too rare to learn from casually. If AlpaMayo helps developers test more edge cases before road deployment, the impact could be significant. The receipts say platform, model, and simulation tools. The implication is that physical AI needs reasoning plus synthetic worlds, not just bigger perception datasets.